Hello, Mr. Aaron, Mr. Ryan. How are you today? Good. Okay.
Yeah.
So, do you still remember palindrome?
Yeah.
Palindrome. So, can you tell me what is a palindrome?
It's a word that's spelled backwards, which is, and it ends up with the same number.
Like
The same
car.
Any other?
Like race car.
Race car. Yes, good
Cool.
idea.
Today we're going to talk about palindrome substrings.
Yes, the palindrome substring. So basically, if I give you a race car and race car, yeah. So you need to tell me the palindrome. How many number of the palindrome substring?
Seven.
Substrings. What's a substring? So basically, it's continuous. You know the subsequence is that you can jump, you can skip, right? Yeah, but substring is not. Is that the substring? Look, R is a substring, I is a substring, AC is a string, AC is a subsequence. So it needs to be continuous piece. Huh? Do you get it? So the palindrome subsequence. Look, race car is a subsequence. Yeah. You continue and look, CEC is a subsequent. Yeah, it's a palindrome substring, right? Yeah, and what, can we find any others? No, I think that's it. Oh, and look, ACECA. Look, ACECA. Yeah, yeah. Got it? Can you find any other things? No. Okay, so yeah, E and each one is a palindrome. So each one R is a palindrome. ACECAR. So we need to count how many of them, right? So for example, this one you need to tell me it's.
So it has to be a palindrome.
Yeah, it has, look, 1, 2, 3, 4, 5, 6, 7. Okay, 7. Plus 1, 2, 1, yeah. Plus 1, yeah. And plus 1. So it has 10 palindrome substrings.
What are they?
Sorry?
What are they?
Look, 7 is each letter, yeah? RACECAR, okay?
Yeah.
1 is ACEC. A, okay? This is a palindrome. Another one, CEC. Another one, race car. Okay?
Why not E?
What E?
Why not just E?
Yeah, I just counted RACECAR. They already counted 1, right? The 1 is already included in each one, yeah?
Yeah.
So that's 10, or that's 10 substrings. Okay? So how can we count it? Any idea? If you're not sure, the first thing you need to think about is.
If there's an even number, all you need to do is you write it down.
Yeah.
And you just divide it by 2 and write what's it divided by 2 and then add it together.
No, it might not work for some strings. I mean, the first algorithm you need to think of is what? To do it the most stupid way, which is brute force, right?
Yeah.
So how can we brute force? So the substring we can brute force use.
Which take a long.
No. Subsequent is O to N, right? We are talking about the substring, which is only how many substrings can we have? If the N, look, Eric, A, B, C, how many substrings?
A, B, C, how many substrings? 0.
No.
B, 1.
A, B,
Four.
C, A, B, B, C, A, B, C. You see?
They're not palindromes.
I know, but I'm talking about the number of the substrings. How many substrings?
No.
How many substrings? So basically, if there are n characters, how many substrings do we have? So if we define the left of a substring is I, the right of a substring can be from anything from I to n, right? Yes? Am I right?
Yeah.
Yeah, so we can, if we use in a for loop for I in range, look away, n, and then we can do this for j in range, start from I to n. So, and then we can get a substring between I to j, yeah? Am I right? Alright? Do you get it, Eric?
Yeah.
This is substring. So what's the complexity of this? What's the time complexity? What's the time complexity if you see two ends, two fours?
And so n square.
Yeah, we're done.
I said that.
Okay, so look,
I said
we need on square to find, to
Cache.
iterate, to brute force, not yet,
Hash.
not yet, to brute force all the substrings in on square. And given a string, given a substring, what's the time complexity if we want to verify it is a palindrome or not? What's the time complexity?
N.
Yes, we're done. So altogether you'll be O cubic, right? Yeah? Okay, so should we write this? Look,
Cubic.
yeah.
N cubic.
Yeah, cubic, n3 to the power of 3.
Yeah.
Power n3. Okay, so define f, let's say s, what's missing?
Column.
Okay, so now let's count the answer equals 0 here, right? Look at it.
Yeah.
For I in range
Yeah.
length n, right? Hold on. For j
Hi.
in range what?
Range.
We can
N.
range I or range, it depends on how you want, okay? Let's say range,
Say S or I.
no, range start from I and ends with length n, right? So what does it mean here? It means, look,
Column.
look, Eric, I determine I, and then every time I have I, and then I loop it from, J will be from I to here, yeah? This is I, and then this is J, okay? Okay? Yes? Alright, do you understand?
Yeah.
So, look, and then how can we check the palindrome? How do we check if the string is a palindrome? Remember?
You stack.
Sorry?
Stack.
Stack? You can use the stack, but commonly how we use it? We
2 pointers.
2 points, or we reverse it, yeah?
Yeah.
Yeah. Oh, let's do it reverse one, which is simple. Look. Look. This is let's say this substring, yeah. Substring equals. Look, Eric. How can we get a substring? S what? S what? Can you write it? S what?
S I.
I, yes, and column and what?
-1.
-1. There's a J here. You want to use it? Do you want to use it? Okay. J plus 1. J plus 1. Look, because this is from the star. This is n. Remember, n is always up to but not including, so we have to plus 1. Am I right? Do you get it, Eric? Look, this is I, and then J will be here, and only I will be J. So every time there's the, if we iterate it, we will have n square substring, right? And look, this is substring. And how can we check if it's the reverse? It's the same. Look, if sub equals, it's reverse. We want to reverse it. How do we reverse this? Remember, we're using this syntax. Column -1, yeah? Remember, this is the, so we look, SUB. Column -1 means to reverse this stuff. If the reverse version is Excel, the same, then we answer what? We want to edit. Answer what? Increment the answer, yeah?
Yeah. Add. Equal 1.
We're done. And then return.
Answer.
We're done. Okay, so look, what's the time complexity?
O(n) square.
This is what?
Cubic!
O(n) cubic. Look, this is O(n). Right, look. O(n) square. And this. Another n here. Look, this is a hidden n here. So it's O(n) cubic. Okay, remember this. Can we do better?
Oh,
I always
we
want to.
can.
Yeah, of course we can. I give you a hint. Dynamic programming.
Programming.
How can we do it?
Memorization.
How can we use the dynamic? Yeah, memorization. So how many kinds of dynamic programming we have?
Memorization.
And
Memorization, not memorization.
so how many kinds of dynamic programming do we have?
Memorization.
I mean,
Top down
Top
and
down.
bottom up.
we're down, top down and bottom up. Yeah, let's go
Top down
down.
is memorization,
With
isn't it?
recursion, yes, and bottom up.
And recursion. And
Okay.
bottom up.
Look, Eric,
Okay.
the problem of previous approach is that we have to check each possible substring to check each substring if it's a palindrome, right? But sometimes we don't need to check, am I right? Do you understand?
Yeah.
Eric, listen. Look, if AB, we know AB is not a palindrome, right? Right?
Yeah.
It's not palindrome. So if I put another C, is it a palindrome?
No.
If I put XX, is it a palindrome?
No.
Of course, because this is not palindrome. So you put any letters around it, it doesn't make it palindrome, right?
But this is a palindrome.
I know. So look, if I use a function Fij, okay? Look, Fij means what? Means the S from I to J plus 1, J, yeah? If this is a palindrome, right? Alright, Eric?
Yeah.
So what does it mean? It equals what? Si equals Sj and, right? Look, if this is a palindrome, yeah, I don't care how many in there, right? If this side, this is at index I, this is at index j. If this needs to a palindrome, it means that these two letters must be the same, right? Yeah? And these inside should be a palindrome, alright? Does it make sense? So this is broken down to this Si equals Sj and what? Can you write it? And F what? Fij means, Eric, Fij means the substring between index I to index j is a palindrome or not. Okay, so it means what? It needs to, the almost characters needs to match. It needs to be the same. So A must equals to B, right? Am I right? Si equals Xj. And what? And what? And this bit. I move here. So this bit, what's this bit? What's the least smaller problem?
It's supposed to be the same.
F what? You just need to tell me what. Fij equals.
Fab.
No.
Aj.
Huh?
Aj.
Fij equals Si equals Xj and what? I move towards each other. Smaller problem.
F.
What?
I.
I what?
I.
I move.
one.
Yeah, and then here.
Yay, -1.
We're done. Got you. Do you
Yeah.
understand? Do you understand?
Yeah.
So we can save this value, right? We can save each Fij. Yeah? Alright?
Yeah.
So we need On square to calculate this Ij
Where?
value. And then we just need O1 constant to get it. So overall time complexity will be On square. We will reduce the complexity to one scale, right? I show you.
Yeah.
I show you.
You saw that rainbow.
Look.
Blue.
Define Fij, yeah? Column, yeah? Okay, so now I'm going to write it, okay? Okay, now I do this. If I bigger than J, I will return true for now. I tell you why, okay? And then else I return
They're not equal.
Si equals Sj and Fi plus 1, J minus 1, right? Yes?
Yeah.
Okay. So look, what's missing in here?
Cash.
Cache, because I need to cache it, right? So after cache, then every pair of Ij will be calculated only once, right? So how many possibility of Ij pairs? How many possibility of Ij pairs? If I is bigger than 0, smaller than, let's say smaller than n, j is bigger than 0 and smaller than n, how many Ij possibility?
N.
N?
No, N minus 1.
So,
No, N minus 2.
minus 2, sorry?
N
Ij.
minus 3.
What you talking about? Look, I
What are you talking about?
I could be from 0 to n, and j would be from 0 to n. So how many possibility of Ij? Okay?
N times N.
Yeah, n times n. This is the complexity of this. Alright? Got it? Okay, now look. We just need to look, answer equals 0, and then we can just do this for I in range n, right? N is the length of the S, yeah? and F for J in range I n, right? If, can you write this bit for me? And I can say return answer. So can you write this if for me? If what? If what? I have a function for you to call. If what? If what? If what? F?
Oh yeah, F.
I, come on. I want to check. I have blue false.
Add.
I what?
No. J.
J. And then answer what?
Equals.
And-
Then add equals 1.
Yeah, do you get it?
Yeah.
So this is On. Look, On square. This is another On square. So all you add together is how many complexity?
O-N square and O-N square.
Is On. On square and On square is what?
O cubic.
No.
O.
On square times n is O cubic. On square plus On square. N square plus n square equals what? 2n square, yeah? 2n square, right?
Yeah.
But we drop the constant. Okay, so it still is On square. Alright? Yes? Do you get it? Because this is constant. I'm only performing 2 times of On square. So the complexity is still On square. Okay? But if I look, Eric, if I move this function, if I move this inside this for, like the first one, the brute force, yeah, Eric, right? Then it's On square times On, right? So in this case, it's On cubic. Do you get it? Yes? Eric, and look, this is answer. Yeah, we can do this in one line, Eric, look, this is a very Python way to calculate. Look, Eric. Remember this, Eric? Look,
Yeah.
you're looking. Look, yeah?
I am.
Okay, so we can do this. We can still keep it and we can return.
I am.
Return, look, F, I, J. For I in, we can do this using this kind of syntax. Range N. And then for
Codon.
J in range I N, right? And then what? And then and this will create an array, a list. And then I just need to count what? Count true. Right? Count the true. And then you will tell me how many of them is palindrome. Because Fij says is what? Is means that the substring between I and J if it's a palindrome. Look at why this I bigger than J is the true. You know why? I tell you, look, Eric. BB, is it a palindrome?
Yeah.
Okay, this is I. This is Z.
Z.
Equal.
BB, Fi and J, they are next to each other, right?
Yeah.
Si equals Sj, right?
Yeah.
So n Fi plus 1, J minus 1. So I will be here, J will be here, right? So I is bigger than J, right?
Yeah.
If that's in the case, I return true, right?
Yeah.
So this will simplify the implementation. If you say this is return false, that's fine, but you have to make this a special case, which is if I plus 1 equals J and Si equals Sj, then return true, right? Otherwise, return Si equals Sj and Fi plus 1 J minus 1. Correct? Yes?
Yeah.
So if I return true, then I don't need that separate check. Yeah? Because in this case, I can still handle this BB. Okay? How about BAB? Yeah? I, J. Alright, look. Si equals Sj. Right. Fi plus 1, J minus 1. So I and J were pointing to A. Still equal, right? Still equal. Yeah? Okay, so this is the beauty of dynamic programming, right? Because we know A is a palindrome. We put 2 similar things on both sides, still palindrome. We put another thing on the both sides, still palindrome. Yeah? Correct?
Yeah.
Yeah? We don't need to check the inside match. Because we already know this is the palindrome. We just keep adding. We are reusing the previous result. Okay? Top down. How about bottom up? What's bottom up? What's top down? Eric?
Yeah.
What's bottom up?
Is that the bottom step up?
Yeah, so we define, look.
You don't use cache.
Yeah, I don't use the cache. Because using cache is for recursion, yeah?
Yeah.
Yeah, recursion. I ask for this value I and j. And then the computer say, okay, I have a cache. Let's check if ij has been calculated before. Right? It has been calculated, we have called it to calculate it, then that's fine. We just take the value without calculating. Do you get it?
Yeah.
Yeah, let's see. It's like you're doing homework, right? You're doing homework. Like Ryan likes to look for the answers, yeah? That's the answer sheet, yeah? Yeah, without actually doing the homework, yeah? Sometimes you do that, right? Yeah, I know you do that, yeah? That answer sheet is the cache. So I pretend I'm Ryan, okay? Ryan, the first question, okay? Okay, and then I check this in the answer sheet. Okay, I found the answer, and then I just directly copy it, right? Yeah, got it? Does it make sense?
I don't.
Okay. Right, Eric, does it make sense? Okay, now bottom up. So we need to create a DP array, right? For the bottom up, we need an array for DP array. DP equals, let's see, true times n for I in range n, okay? So let's create a DP array which contains two-dimensional, yeah? Alright?
Yeah.
And then let's do this. For I in range, let's start from the n-1, from the right hand side. Eric, look. I will start from here to the left. Yeah? To the left. And right, let's look. Star, Eric, look at the range function can take 3 parameters. The star, stop, step -1 means it will be decremented. Start from n-1. Stop -1, but not up to -1. So the last value will be 0, right? And then for j in range I, yeah, I start from I, and then to n. Then I can say dp ij equals si equals sj and what, Eric, can you write it? dpij, this is the array, okay? Si equals sj and what? And what? dp what? And dp what? Can you write it? dp what?
IJ.
dp ij equals si equals sj and
I and 1j minus 1.
yeah, got it. So now we complete.
Bye bye.
Not yet. Completing this, filling this the DP array, and then we can do the same, right? For I equals and then for j equals and if DP ij, then we answer +1. Yeah. This bit is the same. The time complexity is
O-N
what?
cubic.
No. Why is
Square.
O(n) square? Still O(n) square.
Yeah.
Because this bit is O(n) square, and this bit is still O(n) square. O(n) square plus O(n) square.
Is 2n squared.
But we drop the
Drop it.
constant, yeah? So it become O(n) square. What's the space complexity?
O-N cubic.
1
We are using the DP array. Why?
and
Why is that?
A1.
It's a two-dimensional array, so
I want-
square.
O(n) square. Come on.
See?
Because we need the O(n) square space to store all the possibilities of the substrings, right? Am I right? Yes?
Yeah.
Okay, so
Say bye.
which one you think is better?
I don't know.
I think.
Which one?
Bye bye.
I don't know.
You don't know. Okay, so which one you like it?
Bye.
Which one?
Bye bye.
I think
Emma,
I like. I don't know.
Okay, let's say bye bye. See you tomorrow.
Bye bye.
Bye.